This video is part of my series on randomized controlled trials, and this one's talking about blinding. So blinding, or blind trials, or double-blind trials, or whatever, is a term that a lot of people are familiar with but might not be certain what it means. So basically, it means concealing the treatment status of participants to someone in the study, and that's to avoid any bias from preconceived notions of how effective a treatment will be or what it means to be in the placebo group. So a single blind study is when the patient doesn't know what treatment they got, and that's the classic reason that a placebo is used, where everyone in the study is taking a pill, and in that way, people don't know whether they got the placebo pill or the experimental pill, where the placebo usually just has like sugar or nothing, and it's an empty capsule or something like that. And basically, that is the easiest way for the patient to not know which group they're in. So because when the patient knows what treatment group they're in, if they know they're in the treatment group, that they're getting the experimental treatment group, they might be overly optimistic about how effective it'll be. They might overestimate its effectiveness. They also might overestimate side effects, where just things that are unrelated to the medication that they're experiencing over the course of the study, they might falsely attribute to the medication, just because they know they're in the treatment group and they're looking for it extra hard, basically. And when a patient knows that they're in the placebo group, they might underestimate their health status, and also they might seek treatment elsewhere since they know they're not getting a real medication. It might contaminate results in the sense that they're not just sticking to that procedure. They might seek treatment elsewhere. Double blinding is when the patients are blinded to their treatment status, but also the researcher is, and the data collectors. So neither the participant or the researchers and data collectors know whether the patient got the placebo or the experimental treatment. It has the benefits of patient blinding, in addition to so like a non-blinded data collector might bring their conscious or subconscious biases into what they think the treatment effect will be. Subconscious is the more innocent of the two, where if you know someone got the treatment, you might either approach the two groups with unequal vigor. So, for example, if it's like an interview process where there's some subjectivity, if you know someone is in the treatment group, you might be just a little more curious about how they're doing and probe with more questions, or I guess the more like insidious kind is consciously overestimating treatment effects. So like if you really want evidence that your treatment is working and you know someone's in the treatment group, basically you can overestimate how well they're doing. And this is mostly a problem when there's subjectivity. Like if a machine is measuring like some like variables on people, then the machine doesn't care if you are treated or not. But people are very both consciously and subconsciously deceitful to themselves and others. So by blinding both the researcher and the patient, then basically people aren't going to behave accordingly to what treatment the person got, basically. And you're going to approach everyone with equal vigor with how you're collecting their data, and you're going to basically collect data for both groups as objectively as possible. The third kind of blinding is triple blind, and that's when neither the patient, the researcher, or the analyst know whether each patient, or I guess in the case of the analyst, they don't know whether each data point came from the experimental group or the treatment group. There's a surprising amount of subjectivity in statistical analysis. Part of that is choosing what tests to use. I guess there's certain types of analysis where if you try it in a bunch of subtly different ways, you can get different results. And that's kind of scary, because if someone is searching for a result, basically they can, if they are feeling deceptive, they can just kind of keep trying different things until they find the result they want. This can be kind of avoided if you label the treatment and placebo group randomly as like A and B, so the analyst doesn't know which group, A or B, is the treatment and which one's the placebo group. And that way, it's way more difficult for them to take action like they can still take action where there's a significant difference between A and B, but basically like they can't take action that will have some preconceived idea of the fact that the treatment group is supposed to help. This makes it a lot harder for anyone to bring their conscious or subconscious bias into that. And lastly, blinding's not always possible. For example, like if the intervention is some exercise program, the patients obviously know they're doing it. They know they're in the treatment group because they got the exercise. Or same with surgeries. You can get like scars, or you have to go in and have a surgery. I guess in the case of like if it's comparing two surgeries, the patient might not know which one they got, but the scar might help indicate. And then there's like of course unethical things like sham surgeries where like they just kind of like, I'm not sure if that's a real thing. I just was reading about blinding and saw that where like they just make an incision basically and don't do a surgery just so the patient doesn't know whether they got a surgery or just basically a cut. And yeah, so blinding's not always possible, and just because a study didn't blind doesn't necessarily make it not trustworthy. It's more just that when blinding is in place, it holds up to a significantly greater amount of scrutiny. It's almost kind of analogous to like when I was talking about observational studies and randomized control trials. With an observational study, like you're going to constantly be defending that, okay, so we didn't randomize, but we pretty much took into account every potential confounder and we controlled for them accordingly. Randomization is just this like easy and like blunt process that controls all unknown and known confounders. So it's like, fine, I did it. You can't be angry at me now because there's nothing, we randomized, and now it holds up to this scrutiny that there's no unmeasured confounding. Blinding's the same thing. We're like when you don't blind, you can basically argue that like, yeah, we approached this with equal vigor. We took other we did like inter-rater reliability and agreement. We took measures to make sure that there wasn't any bias introduced. But again, blinding is just this like blunt, okay, we did it, like you can't now you can't complain about it basically, that's a potential source of bias. So yeah, the randomized control world takes very blunt approaches where I'm kind of biased just because I'm an epidemiologist, and I think observational studies take a much more nuanced approach.